guys, welcome to application 1-1 focusing on systems of linear equations. I'm here at the lower landing zone at Mount Yonah. This is the part of the trail where the Army Rangers actually use as a setup as their base when they are training on rappelling down the cliffs of Mount Yonah. So it's a pretty cool place to check out. Anyway, to the content of the video, we are going to not necessarily look at word problems today like we normally do with applications, but we're going to look at another way that you might see systems of linear equations presented to you on the milestone and get you familiar and practice with some of those situations. Alright, let's go ahead and jump in and take a look.
Alright, just a reminder of our learning target for application 2B-1 is that I can solve systems of equations by graphing. So let's go ahead and take a look at your application sheet. Let's look at problem number 3. Now, the first thing you'll notice is that this is written a little bit differently than the systems we have been dealing with in the practice and the notes. In the practice and the notes, you saw one equation written on top and a second equation written below that. What you'll notice here, though, is that we are going to have both equations made into one long equation. We're going to have one equation over here, the negative 2x plus 3, and we're going to have a second equation, 5 minus 2x, over on the right side. So what we have to do before we can graph this is to break this up into two separate equations. So I am going to first write an equation for this first side. It's going to be pretty simple. We're going to keep almost everything the same. The only thing that's going to be different is that we're going to say that that is y equals negative 2x plus 3. And that gives us a form that we're more used to graphing. In the same way, we're going to take the 5 minus 2x, and we're going to write that into a separate equation. Y equals 5 minus 2x. So now we need to graph these two equations, and this is going to be pretty much exactly like the practice that you were doing before. We just wanted to make sure that when you saw it crammed into one long equation, that you guys knew how to break it apart into two different ones. So just to recap, this is my left side of this long equation, and this is the right side of my long equation. Alright, so let's go ahead and graph the first one. We had a y-intercept of 3, so I'm going to come over to my y-axis, and I'm going to put a point right there at 0, 3. And my slope is going to be a negative 2, and that means that it's a slope of negative 2 over 1, so I'm going to go down 2 and to the right 1. Down 2 and to the right 1, down 2 and to the right 1, and I'm going to keep doing that. Now remember, we can also go backwards. I could have stuck that negative with the bottom, the denominator, and I could have gone up 2 and left 1. Alright, so I'm going to do my best to draw a straight line. I highly encourage you guys to use your rulers. Can't exactly do a ruler on a smartboard screen. Alright. Now we need to grab our second equation. So on this one, we have a y-intercept of 5. So 1, 2, 3, 4, 5. And our slope is negative 2. Alright, so we are going to go down 2 and over 1. Down 2 and over 1. Down 2 and over 1. And we're going to keep doing that. And you're probably realizing that this is the same slope as our first equation. So what we are going to see is that this is going to make two parallel lines. So if you think back to your notes, our answer for a problem or a system of equations where we had two parallel lines, we had no solution. And the reason again that we have no solution is because these two lines will never cross. Now on your other problems, if you were to graph them and they were not parallel, if you notice below it asks you to give the solutions, your solutions would be wherever these two lines cross. But again, in this example, our two lines are never going to cross because they have the same slope of negative 2. So our only thing that we can say about this is there's no solution. There's no time where these two lines are going to intersect. Also want to show you guys one more way to graph these, and that's going to be using some technology. If you will open a new tab in your Chromebooks and go to www.desmos.com, and I have the link up here. Feel free to pause it and write that down on scratch paper so you can type it into your new tab. I'm going to go ahead and pull that up for just a second. Okay, so when you go to Desmos.com, you're going to get a page that looks like this. And since we are graphing, we are going to want to click the button that says Start Graphing. And it might take a second or two to load depending on the internet speed of the day. I'm at home, so my internet's a little bit slower than at school. And you'll get a graph looking thing like this. So what you're going to want to do is you're going to come over here to the left, and this is going to be where we enter our equations. Now let's look back at our equations. Remember, we had y equals negative 2x plus 3. So I'm just going to type that in right here. Y equals negative 2x plus 3. And you will see that our line magically appears here. We're going to do the same thing with our second equation. Our second equation, if we look back at the smartboard file, was 5 minus 2x, specifically y equals 5 minus 2x. Y equals 5 minus 2x, and we see that it is again graphed. Now, you can also use this keyboard down here to type in numbers, and you can also use it for your x and y. You can also just type into using your keyboard. I find that a little bit easier. Now you notice this is kind of in our way right now that we're done typing. So what I'm going to do is I'm going to just come over here where it says hide keypad. I'm going to click, and it's going to shrink and go away. Now the cool thing about this graph is I can drag it around. I can zoom out. I can zoom in. And I can move to different parts of the graph. So if we look at this, we can see that we do indeed have parallel lines. And you see, even if I zoom out really, really far, those lines are never going to cross. That blue line always stays to the right side, and that red line always stays to the left side. Now, if you ever get completely lost on your graph and have no idea where you are, you can always click this little home button, and it'll take you back to the main screen. Now, just to give you an example, this is a separate example, this is not on your paper, but just of how you would find the intersection on this, let's just say that we had changed this, and this was a slope of negative 4. So what I can do now is if I go up, I can see that these are going to cross. And what I can do to see what this point of intersection is I can zoom in and get closer and closer. And if I click on the two lines, if I click on this line and I click on this line, you'll notice a little dot pops up, a little gray dot pops up where they intersect. And if I move my mouse over there and hover over there, I can see that these intersect at negative 1, 7. Now, your primary way of graphing these should of course be by hand, but this is a tool for you to use to help check your answers. Also on the milestone, there's going to be a graphing calculator that is going to be somewhat similar to this, so we want to start getting you familiar using this type of tool. We'll continue to work on this throughout the year, but we wanted to go ahead and introduce this tool to you today. Now again, just a reminder, this is Desmos.com. Alright, so go ahead and complete your application. Check your answers in the answer binder at the Algebra Embassy, and ask any last minute questions you have, anything that you didn't understand in either the practice or the application, and go ahead and take your mastery check. Good luck. We'll see you in the next video.